Van Leeuwen Trenchless Technologies, or VLTT, enjoys a solid reputation as specialists in a wide range of drilling techniques. It has developed innovative trenchless methods for all land-based crossings, shore approaches and subsea drillings. Ventus Offshore Wind Farm Services is a dedicated service provider with specialist knowledge in offshore wind farm installation and decommissioning, including inspection, repair and maintenance of all supporting components and auxiliary systems. And in 2019 they joined forces to create the consortium Vlcv'S to perform special ventures such as the Borssele shore approach. Vlcv'S was contracted by TENNET to design shore approaches to contain the export cables from Borssele wind farms. Drilling operations start on a barge positioned on the mudflat and punch-out in the pre-dredged exit pit in the Western Scheldt seabed, at a depth of approximately 50 meters.
My name is Maarten Bruggeman. I'm the project lead of the Borssele export cable of TENNET. The project is part of the Net op Zee program of the Dutch government, and we are the first in a series of offshore wind farm connections, and here we connect the Borssele wind farm. Grid connection consists of one land station, 2 platforms, and each platform has 2 export cables. The cables are 350 megawatt each, 250 kilovolts, and the most challenging area is the landfall. The landfall where we go from a navigational channel at -50 towards the land station, and we have to cross a mudflat.
This area is intertidal, with a slope that drops rapidly from 0 to -50 meters over a distance of a few meters, with high currents at the punch-out location and mudflat. This creates a work environment with unique challenges. The chosen solution had never before been executed by any company in the offshore industry.
I'm Vlcv'S. I'm operational manager of Leeuwen Transit Technology and manager of Vlcv'S. After we studied the problem which was brought by TENNET, we determined to use the direct drill technique, which is a single step drilling technique, due to the environmental reasons such as the slope instability and working on the mudflats in the winter season. Challenges are to engineer the right length of the direct drill in relation to the maximum pull force of the cable and designing special disconnection tools for direct drill installation. We also had to engineer and design a special bell mouth to suit the cable and to install that bell mouth on the direct drill pipe at -50 meters water depth.
I'm Paul Vertongeren. I'm the General Manager of Ventus Offshore Wind Farm Services and Commercial Manager of Vlcv'S. Our role in this project was to arrange and contract all the marine assets like barges, DP2 vessel, work class ROVs and offshore trained personnel. We contributed to this project to be involved in the commercial and technical meetings together with the client to seek for the best possible solution for this environment.
In October 2019, mobilization began when Van Leeuwen installed its specialized direct drill rig and necessary equipment on the barge supplied by Ventus. Once fully outfitted, the barge sailed to the drill site location in the vicinity of Vlissingen. Here it positions itself on the mudflat, being firmly secured by ballasting the barge so that she is grounded at the right spot and also secured with appropriate anchors. At the drill site, Vlcv'S is in full swing with the required site preparation for the upcoming drilling operations. The site office, mud plant and drilling equipment are suitably placed, where they will remain operational for the duration of the project. Casings are installed, being necessary to keep the direct drill in position between the barge and entry point, and to maintain mud returns to the barge so that no spill of bentonite flows into the Natura 2000 area. And finally, the overbend constructions, needed to transport the direct drill pipes over the landscape, will be installed at the exact coordinates. The DN400 direct drill pipe sections are readied for welding to one another, conforming to predetermined specifications. The integrity of the welds is checked and verified by a mobile inspection station. Each direct drill pipe section is 12 meters long. When connected together, the finished direct drill pipe will attain a length of 500 meters. When the first pipe is ready, it will be transported from the welding site over the dike, ending at the barge. To accomplish a smooth transport operation, Van Leeuwen installed its special pipe pusher to transport the direct drill pipes over containers and special guiding piles with sliding blocks. Ever so gently, the direct drill pipe moves along its way, and once connected to the direct drill rig, the drilling process can commence. This process is a single-step drill technique, meaning that the onshore prefabricated direct drill pipe is directly connected to the borehole assembly, consisting of mud motor, gyro steering, survey tool, and drill bit. The installation occurs in one pass until the drill is completed at the punch-out location at minus 50 meters of depth in the exit pit in the Western Scheldt. Vlcv has formulated its drilling strategy for this project by carefully considering the subsoil conditions, strength calculations and mud pressures, all of which are implemented in the design scheme.
We gaan met een snelheid van een meter per minuut doorduwen.
After successful drilling and installation of the direct drill pipe, and the punch-out location was verified by a work-class ROV, an HDD rig was installed behind the direct drill pipe to disconnect the borehole assembly with a specially made disconnection system. The crane recovers the downhole assembly after it is disconnected. To ensure that the cable contractor can accomplish smooth cable installation in the future, Vlcv designed a special tool called a bell mouth.
The difficulties of installation of that bell mouth is the zero visibility. We have to connect the bell mouth with an HDD rig and install it at minus 50 meters with work-class ROVs and DP2 vessels onto the direct drill. And that's the most difficult situation of the project.
When we start the hooking, we have 15 centimeters of visibility.
We have to install the bell mouth onto the direct drill pipe, guided by a DP2 vessel and work-class ROV, and connect it remotely onto the drill joint, which pulls it onto the direct drill pipe. When the DP2 vessel crew collected the borehole assembly, they brought a messenger wire and downline to the end of the direct drill pipe and connected it to the drill string. The drill rig then pulled the messenger wire through the direct drill pipe to the barge. Next, the bell mouth is lowered down, guided by downline and a work-class ROV, towards the end of the direct drill pipe. When the bell mouth reaches the direct drill pipe at the right angle and heading, it will be connected to the special connection on the drill string. The HDD rig pulled it to its exact position. The bell mouth is glued to the direct drill pipe, and finally, the drill string is removed from the pipe. After completion of the installation of the two bell mouths, two cofferdams need to be installed at the entry point location on the mudflat. These dams are necessary to install a transition piece by divers at a certain depth, so that the steel direct drill pipe can smoothly cross over towards an HDPE pipe. This project proved a challenge for VLCV due to environmental concerns, existing third-party assets, and a short preparation time. VLCV was successful in navigating these and other challenges during this EPC project. The results demonstrated that VLCV is truly a specialist company for turnkey projects that require a combination of marine and subsea activities using trenchless technologies. No matter if it's never been done before, we accept the challenge and execute with innovation and excellence. Two key factors for a successful tomorrow.